Are you listening through the headphones? Oh, I'm sorry. I thought you were like just listening to music and waiting for me. So, okay. What this really means is we want to write the equation of a line that is parallel to this line and passes through this point. It's kind of misworded, honestly, and I didn't catch that till just now. It should really say, given this line, write an equation of a line passing through -3, 3, -1 that is parallel to the given line. So we basically need to figure out, let me get my notes handy so I don't take too long thinking about this. If our line is going to be parallel, let me put this over here. It will have the same slope. Whoa, that's too big. Get a little smaller font size there. Maybe not that small. So what is the slope of the line given? It would be -3, which is the m value right at the beginning, because y equals mx plus b is what we're looking at, y equals mx plus b, right? So we're going to use that point slope form throughout all these problems. The number in front of x is the slope. So if we're going to use the same slope as that, then for our equation, our m is going to be -3. So that we make sure the line we create is parallel to the other one. Then we want to make it pass through 3, -1. So here's where I'm going to label up here. This point we're going to consider to be a pair of values x and y. And we're going to start with the equation y equals mx plus b, but we're going to fill in what we have. We have for y -1, and then for m, we're going to use -3 to make it parallel. Then we're going to put the value of x, which I just labeled above as 3, and then we're going to do plus b. And what this does, it makes b the only thing still unknown is b, and we can now solve for b. First, by cleaning up a little bit, -3 times 3 is -9. And then add 9 to both sides. +9 minus 1 is going to be 8 over here, equals b. So this is the process of figuring out what b equals. Now we've got the m and we've got the b. We can put it back together. To make the equation, and it will be y equals -3x plus 8. This happens to be some algebra that's not too hard to type because there's no crazy symbols so far. If you get tired of trying to type, you could always go back to, just taking notes on paper. Okay. Tommy?
So if we just put in the slope as -3x, does it matter what the y coordinate is as long as it's not -2?
It does matter, actually, only because we want to make sure that this line passes through this particular point, 3, -1. If we just wanted any line parallel to the other one, we could use whatever we wanted for b. But just to satisfy these particular criteria. Okay, good question. All right, so the next problem is going to be a very similar process. The only difference, we're going to still use this as the original equation, this as the point we want to go through, but we want to make this new line we're going to write an equation for perpendicular to the given line. So the only difference is that we're not going to use the same slope. We're going to use a slope that must be opposite reciprocal of -3. This is, again, a place where I'm going to make the font size smaller because I need more room. So what is the opposite reciprocal of -3? Well, opposite of negative is positive. Opposite reciprocal of 3 is 1/3. So it's going to be positive 1/3 as our slope. This part we're basically going to do again, but we're going to plug in a different slope. Same, the rest is the same. Y equals mx plus b is going to become -1 equals, now the m is 1/3. The x is still 3. We still want to go through that point. And then b is still unknown again. One-third of 3 happens to be a nice round value of 1. So all this, 1/3 times 3 just gets replaced with a 1. And then we have plus b. -1 equals 1 plus b. Subtract 1 from both sides and you get -2 equals b. So now that we have our m and our b, we put it back together to make the final solution. Y equals 1/3 is the slope x minus 2. That's the equation of a line that is perpendicular to that line and goes through the point 3, -1. So we did a couple of these together last time. I know it takes practice to kind of get back into that. You should have been able to recognize that you've done this last year in algebra. Before March, it was well earlier in the year. So it might be seeming like a long time ago, so it's a little rusty, but just keep using y equals mx plus b, replace what you know, solve for what you don't know. The goal is to get a slope and an intercept for your final equation using what you've got. Now, question 2 is quite a bit more work than either of those, because here's the steps we're going to have to take. Step 1, oh gosh, I'm going to need much smaller font again. We'll go with 14. To find the distance from a point to a line, we first have to figure out where on the line. Remember, distance is a perpendicular. So from a point to the line, you have to be able to find the perpendicular line and figure out what is the point where the perpendicular intersects with the line. Then you got to find the distance between that point and the original point. So we need to, step 1, find the equation of a line that goes through 6, -2 and is perpendicular to the line y equals 2x minus 4. Now I'm going to try to see how it looks if I draw on my screen for this on Cami, just out of curiosity. If I were trying to use slope, oh gosh, nope. I can tell already, bad idea. Back to just typing. Text box, there we go. All right, so the slope of a line that is perpendicular to 2x minus 4 is going to have to be opposite reciprocal of 2. The opposite reciprocal of 2 is negative 1 over 2. Then I'm going to proceed to do this whole process up here again. Start with y equals mx plus b, and then replace the y with the point up here. This is going to be considered my x comma y. I'm labeling 6, negative 2 is x comma y. So the y is negative 2. The slope is negative 1/2. The x is going to be 6. And then we have plus b. Now to work out a little further, make this, clean it up. Negative 1/2 times 6 is negative 3. And then we would want to get b by itself, so we add 3 to both sides. 3 plus negative 2 is 1. Therefore, b equals 1. What is going on, Tommy? You got like a fan in front of your camera there, or it's just like, it was like flashing. Tommy wins the day for getting my attention on the Zoom. Okay, so now we found the b. We can put the equation back together. Text box, I'm gonna need another text box here. Uh-oh, there we go. So the equation is gonna be y equals negative 1/2 x plus 1. All right, that's only step 1 of this problem. Now I know an equation that is perpendicular to the line and starts, it goes through that point. I'm trying to find the distance from the point to the line 2x minus 4. And the distance is always along a perpendicular. That's why I had to find that perpendicular line. Now, to figure out where the perpendicular intersects with the original line, I have to solve a system of these two equations together. That's why I told you this is like really like a 3-part algebra problem. Step 2, find the point of intersection between the two lines by solving a system. So the system would look like this. Y equals 2x minus 4, and y equals negative 1/2 x plus 1. Whenever I have a system like this where both equations are in slope-intercept form, I pretty much choose to go with either substitution or graphing for solving the system. I don't feel like pulling up a graph. Maybe, you know what? Maybe graphing would be quicker than solving it algebraically. You could solve this by substitution. I'll just show substitution method. Because both of the right-hand sides are equal to y on the left-hand side, you could just set the two right-hand sides equal to each other because they both equal the same thing. So negative 1/2 x plus 1. Okay. If you're going to set up substitution, you would set up that equation and solve it, which is not actually that hard. But there's another way. You could do graphing because they're both in slope-intercept form. So I'm going to actually open a new tab. Are you guys seeing my new Google tab? Okay, I'm going to go to Desmos. because Desmos has a graphing calculator where I could just type these two equations, y equals 2x minus 4 and y equals negative 1/2. I'm going to put 0.5 just to make sure it doesn't do anything weird with the fraction. X plus 1. Okay, hey, there's the point of intersection. And what I love about this is I can see that on this line, the point 6, -2, there's the original point. We're trying to find the distance between 6, -2 and the red line. So now I can see that the intersection of these, like going perpendicular to that line, the point 20 is our spot that we're going to calculate the distance between this and that. Okay, so 20, that's my solution to the system. So the solution to the system there is 20. All right, so step 3 is basically just find the distance between 6, -2, the original point, and 20. And this is just distance formula. Now, distance formula is a little harder to show with the big old square root when we're typing. But I'm just going to put everything that's under the square root as typing, and then I'm going to basically draw in the square root afterwards. Why will it not let me move? Okay, here we go. So the distance between these 2 points is going to be big old square root. A V could serve as the beginning of it, or you could just say SQRT and then in parentheses everything else. Okay, that's another way to do it. I'm going to put everything else in brackets because I'm going to have parentheses inside that square root also. Basically, it's y2 minus y1 squared plus x2 minus x1 squared. So y2 minus y1 is going to be 0 minus -2. And then squared, let's see. In typing, that's a symbol for squaring. A little caret and a 2. That means raised to the power of 2. Plus, now x2 minus x1, 2 minus 6. And then raised to the power of 2. And all that is inside the square root. Okay. So the distance between these 2 points is the square root of 0 minus -2 is 2. 2 squared is 4. Plus 2 minus 6 is -4. -4 squared is 16. So the next line would read square root of 4 plus 16, which is square root of 20. Now I know this looks very odd and foreign the way we're writing out the square root, but basically radical 20 is the answer. In a calculator, you could get the decimal version of that. Square root of 20. Okay, my calculator, when I put in square root of 20, turns it to a simplified radical of 2 radical 5. But then if you hit the toggle button, you get, whoops, that wasn't a toggle button, 4.472. All right, so that's the approximate answer. 2 radical 5 is the exact answer. So that's the distance from 0.6 negative 2 to the line 2x minus 4. In order to find the distance, you have to go perpendicular. So it requires figuring out the line perpendicular and finding where it intersects with the line. This is like a big process. Let me just put approximately 4.47 from the calculator. And that's the final answer. Okay, today we're just going to add a little bit more to that and practice more of pretty much the same. Again, we're going to review a bunch of concepts from algebra as we go, and actually from earlier in this year. So here's a new definition on the next page. Perpendicular bisector is a line that passes through a segment and bisects it into two equal parts. It goes through the midpoint of the segment. And it actually, because it's perpendicular, it will form four right angles. The line and the segment it's bisecting. So that's the definition of a perpendicular bisector. Now in example 1, it doesn't actually say find the equation of the perpendicular bisector for this segment, but that's really what we're doing. We are going to first find the midpoint of the segment formed by these 2 points. It should really say segment there. I kind of feel like with the 2 points as endpoints, we're really talking about a segment. Okay. Then we're going to write the equation for the line that passes through the midpoint and is perpendicular to this line. So first we need to find the midpoint. Step 1, find midpoint. Not midpoint, midpoint. Remember, the midpoint is the average of the endpoints of a segment. And it has a formula. This is really going to be a hard formula to show by text. If you're typing, at this point, I almost might want to just say, let's revert to writing it by hand. It's going to be much quicker. But anyway, the midpoint is the average of the endpoints. So let me just talk through this. We have to find the average of -5 and 3 for the x coordinate, because the x coordinates of those endpoints are -5 and 3. And then for the y coordinate, we have to find the average of -5 and 3 again, because the y coordinates are also -5 and 3, because they have -5, -5, and 3, 3. So whatever we find as the average for -5 and 3 is going to be both coordinates of the midpoint. So what is the average of -5 and 3? -5 plus 3 divided by 2. And basically that again. Can I copy and paste that in here? Yeah, it looks terrible. I'd rather write this out by hand, but -5 plus 3 is -2. -2 divided by 2 is -1. So the midpoint, both coordinates are -1. Now that we know the midpoint, we have the point that our line is supposed to pass through, and it's supposed to be perpendicular to the original line. Now, we were not given the equation of the original line so that we could take the slope and find a perpendicular slope from it. We were given points. So the next step here, step 2, is to find the slope of the original line so that we can find the slope of our line that's perpendicular to it. So step 2, find slope of the original line. If you want to just write find slope of original line, go ahead. Be dweeb. Typos are sometimes funny. Okay. So the slope of the line between these is going to be y2 minus y1 over x2 minus x1. I'm going to write this in 2 lines of typing, rise and run, okay? So that I can kind of show it as a fraction. The rise is the y2 minus y1, and I'll just type y2 minus y1, okay? And that equals, in this case, 3 minus negative 5. And then we're looking at a fraction. I'm going to try this. Put fraction bars. Kind of like this. Maybe if I use underscore, it would be a solid line, but you get the idea. Then we have x2 minus x1 on the bottom of the fraction. In this case, x2 minus x1 is also 3 minus negative 5. So the final answer for the slope is going to be 8 on the top, 3 plus 5, over 8 on the bottom, which equals 1. The slope of the line that they gave us is 1. If we had put this on a graph, we probably could have easily counted up over, rise, run, 8, 8, it's 1. But showing our work here. All right, the next step is to find, step 3, is to identify the slope of a line perpendicular to that. So in this case, the slope has to be opposite reciprocal of positive 1. Because we're trying to write an equation for a line that's perpendicular to that and goes through the midpoint of negative 1, negative 1. Okay. The opposite reciprocal of of positive 1 would be negative 1 over 1, which is also just negative 1. And then finally, step 4 is write the equation of a line with slope m equals negative 1 that goes through midpoint negative 1, negative 1. And this is the same process we were doing in the warm-up, where you start with y equals mx plus b. Then you plug in what you've got. The y is negative 1, the slope is negative 1, and the x is negative 1. But the b is not known yet. That's what we're going to solve for. So multiply negative 1 times negative 1 over there. That makes a positive 1 plus b. Now subtract 1 from both sides to get b by itself, and you end up with negative 2 is equal to b. Then you put it back together, and we have, ta-da, our final answer. Y equals negative 1 for the slope, x plus negative 2, or just minus 2 for the b value. Maybe I'll show one more time. Y equals mx plus b is what we're doing there. Putting it back together. So the equation of the line that goes through the midpoint and has a slope perpendicular to the original segment is this: y equals negative 1x minus 2. Wow, that was a long one. Not nearly as long as some of the 5-page problems that we do in calculus in college if you're a math major. Problems go on and on and on. But by that point, you're really into it and you'll love it. And you want to wallpaper your walls with it because you're just so passionate about math. If you decide to become a math major in college, you'll know what I'm talking about. Anyway, we have another example to do similar to that, but I feel like we don't have time. We only have 20 minutes left and there's more other material in here. So part B would be, we're gonna just put in here another example for another time. If you want more practice, you can try this one, follow the exact same steps as up here. It's just different numbers, okay? And you know what I'll do? I'll give you a reveal so that if you do try this to practice more on your own, the answer should come out to be y equals negative 1x plus 1. Okay, but same process as above. Now there's one more topic in this set of notes here. We are in section 3.5. 3.5 is jam-packed with stuff about equations of lines that are parallel and perpendicular. This is like our second day doing notes on 3.5. We're going to learn how we can answer a question like this. If you are given a segment like you see on the screen, AB, goes through 3, 2, and 6, 8, and you want to partition that segment into 2 pieces, but not half and half. I mean, it could work for half and half also, but something beyond just finding the midpoint, okay? Where you want to find the coordinates of a point along this line so that we're going to place point P somewhere so that when you look at AP and PB, you end up with 2 segments that are in a ratio of 3 to 2. Okay. I'm actually going to ask you to kind of like just watch me do this with a simpler example first. Okay. Because this example comes out really crazy decimal and it's not very intuitive. But I would like to show you an example that is more intuitive, and that will kind of reveal how to do this problem. You see there are steps on the screen. It's not really like a mystery. You can follow the steps, but I will have to show you how. And I think with a problem that has numbers that come out nicer and it will be easier to see would be a good idea. So I have to do this one on paper. And I'm just going to join real quick from my phone again. Gotta be let in. Okay, you may want to you want to kind of have your notes in front of you, but take a look at this problem that I'm going to make. All right. I don't know if you guys can see that. Is this paper like big on your screen or no? Let me stop the sharing of the screen. Nope. Okay, I've got these 2 points, 2, 1, and 7, 11. I chose these specifically because there's a nice, it's a much easier problem. If we call this A and this is B, and then we're looking to find a point P, find P so that the ratio of AP to PB is 3 to 2, okay? From A to B, if we count, this is 2, 1, and this is 7, 11, okay? The slope from A to B, if we do it algebraically, the rise from 1 to 11 is 10, okay? And the run from 2 to 7 is only 5. So it's rise 10, run 5, okay? Rise, run. So the slope is up 2 over 1, up 2 over 1, up 2 over 1. Now, the directions say we should calculate the slope, which I just did. And it says, make the ratio of 3 to 2 into a fraction, okay? So just watch this. To make this ratio 3 to 2 into a fraction, we want to picture that if we were to divide this segment up like into really 5 equal pieces, not 3, not 2, but 5 equal pieces, 3 of them would be on one side of P and 2 of them would be on the other. So really we're dividing up the segment into 5 parts. So the fraction that we would be creating here is not 3 over 2, it's 3 over 5. You have to add the 2 numbers together and put that as the denominator. And then 3 over 5 is the fraction that we want AP to represent compared to PB. So AP is going to be 3/5 of the segment, and PB is going to be 2/5 of the segment. Okay, so you add the 2 numbers together for the bottom, and then you put the first number on top, 3 out of 5. Okay, So step 1 was calculate slope. Here's that. Step 2 is calculate the fraction. It's 3/5. You know what? Even on your paper, if you just want to change the numbers of A and B and it won't match the graph, just so you can kind of follow along, we might as well do that. Part 3, step 3, is to multiply the change in X. This is the change in X, right? Run is always change in X. Multiply the change in X and the change in Y by our fraction. So change in X is 5. Multiplied by 3/5, that would be 5 times 3/5 is 15/5 equals 3. When we multiply the change in Y by the fraction 3/5, oh, the change in Y is 10. That's the rise. 10 times 3/5, 30 divided by 5 is 6. So 3 and 6 are my new, like, change in Y and change in X. 6 and 3. Rise and run. Remember that Y corresponds to rise and run, and X corresponds to run. So basically, we would want to start at A, and instead of rising 10, running 5, we would want to rise 6, run 3, and that would get us to a point where we've partitioned it up into 3/5 fraction. So starting at 2, 1, if I rise 6 and run 3, basically I'm adding 6 to the 1, I'm getting 7. I'm adding 3 to the 2, I'm getting 5. The 0.57, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. If I were to put the 0.57 there, that partitions this up into like 3 parts over here, 2 parts over there. Again, it would be a lot easier to see on an actual graph, but the numbers for the problem on your paper come out to be decimals, so it's even harder to kind of justify. All right, but that is the steps that we would take to do this. Let's do it with example 2 together on the bottom. What time are we having? Okay, we still have 10 minutes to do this last example together. So the one I just showed you on the paper was not actually on your page. I'm going to just go down to example 2 and do each step fresh. Okay, make a text box. Step 1. A little too big. We need to calculate the slope of the current line. You could count on the graph. You could do rise and run, you know, down and over if you want, or you can do coordinates. When I look at it, calculating the slope on the graph, it looks to be, because the graph is labeled by 2's, it's a little less obvious. So I actually decided to go with rise and run and do the calculations of y2 minus y1 over x2 minus x1. That's way too small, isn't it? I don't know how to change the font after I've created something. It's okay, there it goes. So for this equation, for this line, the y2 minus y1 would be -3 minus 5. Which would be -8. And you can see you go down 8 from from 5 to -3. The x2 minus x1 is 8 minus -4. Eight minus -4 is 12. So even though it doesn't count that way on the grid, if you look at the coordinates from -4 to +8, that would be a difference of 12. So that's the change in X versus and change in Y. I'm just going to put a little bar between them as a fraction. Step 2. Make the ratio into a fraction. Now, in this case, the ratio 3 to 5. How many total parts are there of the line that we're going to break it up into? If there's 3 on one side and 5 on the other, that's a total of 8 parts. So we're sectioning up this line into 8 parts, and we want 3 on one side and 5 on the other. So that means the ratio should be 3/8. Take the two numbers, add them together, that's your denominator. The first number is your numerator. Step 3 says multiply the change in Y and change in X by that fraction. So I had my change in Y on the top, it's -8. So change in Y, -8 times the fraction 3/8 is going to be -3. That'll be like, you know, what I add to the Y coordinate to get to the new point that's going to produce this division of 3 and 5. The change in X on the bottom of the fraction of the slope is 12. I'm going to multiply that by 3/8. And so 12 times 3 is 36. 36 divided by 8 is 4.5. Now, step 4 says add these values to the coordinates of C. At point C, you're just going to add a -3 to the Y and a 4.5 to the X. So C starts off as -4, 5, and it's going to become, I'm just going to draw like a little arrow type of thing there. It's going to become, for the new point, -4 plus 4.5 and 5 plus -3. So the new coordinates of this point that will partition up the segment are 0.5, 0.5, comma 2. Now, if you look on the graph, 0.5, comma 2, it would be about where my cursor is right here. And you can kind of imagine three portions of the line on the left side of that and 5 portions on the right. It's not easy to envision because we're talking decimals and we're on a diagonal and all that, but there we have it. Okay, it is 9:40. This class goes to what, 9:45? It's just 9:45. All right. So I just want to basically use the last 5 minutes to address a couple of things. First of all, I realized that the example 1 is not filled in here, and I have all these notes done by hand that I think I'll just take a snapshot of them and I will post it as a PDF so that you could kind of take a look at the last 2 examples. They're just more examples of the same thing, different points, different ratios, okay? But that way you'll have example 1 done out, even though it's decimals and it's hard to like imagine the ratio on the graph. You could try examples 3 and 4 to fill in from my notes. But secondly, tonight's homework is once again to do some more Alex topics. I know there have been a few, well, I've heard from one person who said they were having trouble finding the topics. So I just want to show you one more time. First of all, I reattached the same topic document to today's post. I'm kind of curious. When you open this topics document, did anybody start checking off? I know Nicole, right? Or Noelle? You started checking off the ones that you had completed in this document? Noelle? Can you unmute yourself?
Yeah, sorry, it was not
Okay.
a meeting.
Back on Tuesday, Monday, when I gave you this document, I saw that you had checked off some things, right?
Yeah.
Now, when you open today's document, does it still show those check marks? Is it still accessing the same document for you? Or is it giving you like a fresh copy? Did you say something? All right, can you type that in the chat because your voice is breaking up, unfortunately. But anyway, whether you have a new copy of this or not, this is the place to find out what topics I'm talking about. So for homework tonight,
Document.
I'm getting cross audio like after the fact. Okay, it just gives you a blank document. All right. I was hoping that if I reattached it, it would give you the option to not replace the document you had, but like reopen the old one. It didn't do that. I'm sorry. But anyway, you've got the list of topics here. I would like you tonight to go in and try to find topics 22 to 25, which are solving a system to get more practice back from algebra using substitution, solving a system with elimination, and then finding points that partition a number line into segments, okay? Just like in a given ratio, just like I just showed you. So these are the 4 topics I would like you to try to find in Alex. If you need to, I will show you really quickly again how to select topics. When you go to Clever, let's see if I can log in real quick and show you as a student. Alex is under McGraw-Hill. We got 1 minute. Launch Alex. I got to get into a student version of one of the classes. You'll have to select chapter 3, and then you can try to find the topics using a search, probably the quickest way rather than scrolling through. But let's say I go to the student view and I have my pie come up. If you know how to do this and you're fine, you can leave. But if you're not sure and you're having trouble finding topics, just watch real quick. Top corner, pull down the menu. You have another menu that allows you to choose topics, chapters. Once you're under chapter, you can go to the filters and you can search for the topic right there. Okay, or you can just scroll through. But hopefully the very end you would find them. Otherwise, try typing in the topic name. Okay. So That's your homework. Try to get those 4 topics done in Alex. All right, I will see you again on Friday. Have a good one. Mark,
Yeah, sorry, I didn't know if you saw it last night.
what, last night?
Yeah, I emailed about the Alex. My assignments were locked for the homework, so I couldn't do it.
Oh, no, I didn't check my email yet today.
That's fine.
So, I mean, you can always catch up. If they were locked, the reason I did investigate this, because someone else said the same thing. And basically, if you did not complete previous chapter topics, they may have locked these topics because you didn't do the prerequisites for them. So
Okay, I'll
I don't
check
know
it.
if you're behind on earlier stuff, but you may have to go back and finish other topics from previous chapters.
All right. Okay.
Okay.
Thank you.
All right. Take care.